So continuing on the topic of evaluating an integral using fundamental theorem of calculus that requires U-substitution, I'm going to do part D on this review sheet for calculus. And again, I am solving these problems not in a way of teaching how to solve it, but actually just solving a problem and explaining my steps. So here, we're going to do the integral from 0 to 1, 8 cosine pi t over 2 dt. So first step again is going to be to find the antiderivative. But to find the antiderivative, this is not a simple thing to find the antiderivative of. So therefore, when it's not simple, we do substitution. So I'm going to let u equal to the complicated part of this problem. The complicated part of this problem is the inside of cosine, which is pi over 2t. When I do u substitution, I'm going to substitute u in for this crazy looking thing. But when I substitute u in here, I need to substitute dt in terms of u as well. So I'm going to take the derivative of this. I'm going to get du over dt is equal to pi over 2. And I actually want to isolate my dt. So first of all, I'm going to multiply the dt over there. So I get du is equal to pi over 2 dt. And lastly, to isolate my dt, I'm going to get dt is equal to 2 over pi du. So here's my dt. So I'm going to substitute pi over 2t with u, and dt, I'm going to substitute that with 2 over pi du, so that everything's in terms of u. So just to make this a little bit nicer and neater, I'm going to have the integral, and I'm going to put star and double star as placeholders for the bounds. So I'm going to get 8 cosine u times 2 pi times du. So notice 8 and 2 pi are merely just constants, so I'm going to bring that out in the front. So I have 16 over pi integral with a placeholder star and double star cosine u du. And what do you know? Cosine u is way simpler to find the derivative of than that ugly looking thing up there. So I'm sorry, not the derivative, the antiderivative. So the antiderivative of this is going to be 16 over pi. Antiderivative of cosine u is going to be sine u. And again, check your work. Is the derivative of sine cosine? Yes, it is. Okay, and then this is going to go from star to double star bounds. So notice I started off with t and then we end up with u. So I'm going to substitute the t back in because that's what we're really interested in. So right now I have 16 over pi sine. And what is u? U is pi over 2t. So I have pi over 2t. And this is going to go from, now I'm going to substitute the 0 and the 1 in because now I am back in terms of t. And this is really hard to do with one hand as I'm holding my phone and writing at the same time. Okay, so now I'm ready to use the fundamental theorem of calculus. To use the fundamental theorem of calculus, I'm going to do bracket, bracket, minus bracket, bracket. Okay, so in here I'm going to have f of 1 minus f of 0. F of 1 is b and f of 0 is a. So f of b minus f of a is the fundamental theorem of calculus. So when I substitute this in, I have 16 over pi sine. Well, if I plug a 1 into this, it's just going to become pi over 2. Next, I'm going to plug 0 in here, so I have 16 over pi, and then if I plug 0 in here, I have sine of 0. Great. So, to solve this problem now, we merely just simplify. Sine of 0 is just going to give me 0. So sine of 0 is just going to be 0, so this whole thing zeroes out. Sine of pi over 2, so honestly, I have a hard time remembering the trig functions, so I draw a picture. That's my sine graph. This is 0, 2 pi, pi, pi over 2. Okay, so sine of 0 is 0. Sine of pi over 2, its peak here is going to be 1. So that's how I remember it. So I have 1. So all in all, the answer that you end up getting is equal to 16 over